Good morning. As has been told by Gianni, the Stabiwine project is a large effort with a lot of resources invested in it, and its main focus is the development of new additives for wine stabilization. And when you are developing a new additive, a very important task is to control that this additive is not going to impact the flavor or taste of your product. And this was our task in the Stabiwine project. It was to assess the sensory impact that polyaspartate, potassium polyaspartate, could have on the flavor of wines. And we did that by both chemical and sensory analysis. And this is the results I'm going to show you today. We ran some preliminary sensory test, descriptive, duo, trio, triangle test. And first I want to show you a descriptive test about the 4 basic tastes of wine. You can see in the figure the sweetness, sourness, saltiness, astringency and bitterness in a scale of 0 to 3 as evaluated by the tasters. And the blue line is the control wine, and the red line is the same wine added with potassium polyaspartate at doses of 27 grams per hectoliter, which is a very high doses, is more than usual. And it was just because we want to be sure that there was no impact there. And the results are that the assessors were not able to find significant differences in the taste regarding these basic tastes. So after that, we ran a duo-trio experiment. I guess you are familiar with this kind of test, but I will remind you very fast how it works. The assessors are presented with 3 samples. One of them is labeled as reference, and the other 2 samples are blind-coded. And first, the tasters have to assess the reference, and then they have to assess the other 2 blind-coded samples and found the most similar one to the reference. So we did that with our with potassium polyaspartate, and for the reference we used the wine that was not the control wine, and the other blind sample was the wine added with potassium polyaspartate. And the fact is that the tasters were not able to distinguish between them. They didn't find significant differences in aroma or taste. And with that, we did this after 3 and 6 months of contact, and in several wines, several young white wines, and also in a young red wine. But however, in a different sample, in a different red wine, we found something different. And again, it's the same experiment. It's a duo-trio after 3 and 6 months. And in this case, again, the reference is the wine without addition. And we have another sample with the potassium polyaspartate. And in this case, the tasters were able to find differences in aroma. And after a more detailed evaluation, we found that both the reference was oxidized. The wine presented oxidizing notes, development notes of oxidation. But, this was not the case with the sample added with potassium polyaspartate. So keep in mind that these were the same, exactly the same wine, kept for 6 months in the same conditions, and the only difference was the addition of potassium polyaspartate. And our hypothesis for this is that maybe potassium polyaspartate could have a chelating effect on iron and copper. And if you remember from yesterday, the presentation, the nice presentation of Mauricio Ugliano, he showed us a slide, and if you remember, iron is the catalyst of all the oxidation phenomena in the wine, and maybe this chelating effect could prevent this catalytic effect. So about this, more experiments are currently on progress. Well, after these preliminary experiments, we carry out a large experiment. In this case, we take a larger amount of wine, white wine, and we split it in two halves. To one of them, we added potassium polyaspartate, and to the other half, we added metatartaric acid at 10 grams per hectoliter. And again, we divided the samples. To half of them, we added Arabic gum, 1 milliliter per liter. And again, another split of the samples to add ascorbic acid at 5 grams per hectoliter. And we kept all these wines that represent 16 samples. If we add their replicates, we kept them for 1 year, and we ran analysis after 48 hours, 6 months, and 12 months. And of course, we did the same with our red wine, the same procedure. Potassium polyaspartate of metatartaric acid, Arabic gum, and in this case, instead of ascorbic acid, like in the white wine, we use L-gitanians at 5 grams per hectoliter, and again, we kept the samples for 1 year and ran analysis after 48 hours, 6 and 12 months. And which kind of analysis did we make? Our specialty is the analysis of wine aroma, and for this we use sensory and volatile analysis, and I want to show you very fast how it works for one of our methods. This is based on solid phase extraction, and we use a sorbent where we retain the volatile compounds. After retaining them in the sorbent, we use an organic solvent to remove selectively the volatile compounds, and then we use a chromatographic system to obtain data from it. We inject them in a gas chromatograph. We separate them because there are many volatile compounds. We separate them and we detect them in a detector that in this example is a mass spectrometer. And from there we obtain qualitative and quantitative data. And with several analytical methods, we are able to analyze all the compounds that are important for wine aroma, that range from the hundreds of milligrams per liter to the few nanograms per liter, like compounds that have been mentioned here, like rotundone or varietal thiols. So with this experiment, we have 16 different samples for each wine and data, and this represented almost 100 samples. And for each sample, we analyze 11 routine enological parameters, including tartaric instability. This is the data that Antonella has commented before, and I will not enter there. And of course, 67 different volatile compounds. We have data for them, for the 100 samples, more or less. And also, we carry out 6 sessions of sensory analysis. And I want to show you some very short summary of the results, some examples. So, for example, isomyl acetate, as you know, is the main compound responsible for banana aroma in wines. And you can see here on orange the results for, in the bars in orange, the results for the wines added with potassium polyaspartate and different additives like Arabic gum or ascorbic acid. And the blue bars are the results for the wines added with metatartaric acid. And what you can see here is that the differences are minimal and are not significant from a sensory point of view. Also, I want to show you linalool. Linalool in white wines, since some white wines can be responsible for a floral note, and the same thing. The figure on your left is the 6 months results, and on your right is the 12 months results. And maybe in this case, in the 12 months figure, you can see a little bit higher the content of linalool in white wines, but these differences are likely to have any impact on aroma. In red wines, also a very well-known compound, isomyl alcohol, one of the responsible for the vinous aroma of wines. Again, you can see the differences are in the error of the analysis. There are no differences between treatments. Another compound, ethyl dihydrocinamide, responsible for floral notes, white floral notes in some red wines. And again, there are no differences here. So, in summary, we carried out a lot of experiments. Several of them were very large, implying a lot of analysis, sensory analysis, volatile compound analysis, and we didn't find any differences. The sensory data also support that. So our conclusion is that potassium polyaspartate did not alter the flavor profile of red wines. And just to end my presentation, some acknowledgements. Of course, you can imagine this is the work of a lot of people, and I want to thank our laboratory in the University of Zaragoza, especially my colleagues, Professor Vicente Ferreira and Professor Puri Hernandez, and our PhD student, Eduardo Vela, and of course to Enartis and the Stabiwine project for their financial support, and all of you for your kind attention. Thank you.